Hey everyone, welcome back. Got another lesson for you. But first of all, I just want to say again, always hope you're healthy. Hope everyone in your family is doing healthy. And then second of all, hope you continue to think and pray for those who are not as lucky and not as healthy and able as we are to survive and hang in there during these times. So anyway, yeah, so let's get started on our new lesson. We're moving on to 8-3, of course. And this is going to be a little bit more challenging than the previous part, just because adding and subtracting gets a little bit more complicated. There's a lot more work to do by hand and all that. So, but again, the whole point is that, the whole chapter is about rational expressions. So we are going to relate it as much as possible to fractions, because rational expressions are basically fractions just with polynomials and variables, right? So we're going to do our best here to relate it as much as possible to fractions. So let's get started. Here we got 8-3, and it's all adding and subtracting, of course, right? And I have a quick reminder here. So when we're adding and subtracting, so remember with fractions, the only way to add and subtract fractions are if your denominators are the same, right? So in this first example, if I have 1/7 plus 4/7, the denominators must match, of course. And so if they do, we're good to go. And if you have the denominators matching, if you're adding and subtracting, the denominators are not going to change, right? The whole point for the denominators to match is that the denominator stays the same. Because if I have 1/7 and 4/7, I'm going to end up with sevenths still, of course. And what you add are the numerators. So you just add straight across on top, and 1 plus 4, of course, is 5. So 1/7 and 4/7 is 5/7. And subtraction exactly the same. The denominators are not going to change. They have to match, of course. So if I have 7/8 and I'm going to subtract 4/8, all I do is subtract the top, the numerators. So 7/8 minus 4/8 is going to give me 3 left over, 3/8, right? So the same applies to rational expressions. And so we're going to just start with, these easy examples here where the denominators are going to match, okay? So here's our first example. I've got 5 over x plus 2, and I'm going to add 5x over x plus 2, and I'm going to add 6x over x plus 2. Of course, the first step is check if the denominators match. Can you add or subtract? And I can, right? Because I've got x plus 2 and x plus 2. So I can go ahead without any problems. So then I just proceed with adding and subtracting combined like terms. And that combined like terms is important because, obviously you can have lots of different variables up there. So just combine what you can. This problem's not too bad because I'm going to combine the numerators, 5x plus 6x over x plus 2, because the denominator matches. And 5x and 6x can combine to make 11x. So my final answer is 11x over x plus 2. And typically you're going to want to just always, just in case, check if your final answer can be simplified or factored even more. And in this case, it can't, right? There's nothing that can factor or cancel out. So this is our final answer here. And just to add a little bit extra, in this case, right, we always want to check with rational expressions, that our variable is not going to run into any problems. Because I have x plus 2 in the denominator here, right? I can't have x equal to -2, because if x equals -2, right? If x equals -2, that means this bottom part here is going to equal 0, and I can't divide by 0. So just always keep that in mind in case you have problems that ask you that. What are the restrictions, or what are the solutions that your variable can equal? And in this case, it's just -2. Okay, so we don't want the denominator to equal 0, but that's just a little sidebar. All right, let's keep going. Here we go. All right, just a couple more examples. Here again, I've got a subtraction problem now. I've got 2x minus 1 over x squared plus 2 minus 4x plus 4 over x squared plus 2. So the denominators match. That's why I circled them. So we're ready to just combine like terms on the top. You always want to be careful when you're doing that with addition and subtraction, just because the signs, you want the signs to work out correctly, right? So what you're going to do here is always just use parentheses. Even with addition, whatever you're adding and subtracting, the second thing, just put around parentheses so you make sure you distribute the sign correctly. So my denominators match, so I'm just going to rewrite my denominator here, x squared plus 2. And so my top part, my numerator, is going to be 2x minus 1 minus, right? So minus right here, and in parentheses 4x plus 4, because I do have to I have to subtract both of them, and that means that the minus is going to distribute to both parts. So that's why in this second step I have 2x minus 1 minus 4x minus 4. Okay, and then again you just combine like terms, right? And I've got 2x minus 4x is going to give me negative 2x, and then negative 1 minus 4 is going to be negative 5. So my final answer is right here, negative 2x minus 5 all over x squared plus 2. And again, that can't be simplified or factored. So you're good to go. All right. And then, yeah, let's keep going. So last example, I think. I've got 3x squared minus 5 over 3x minus 1 minus again. And I'm subtracting 2x squared minus 3x minus 2 over 3x minus 1. Denominators match, so this is not too bad. All I have to do is combine the like terms at the top. So I rewrite my 3x minus 1 denominator at the bottom, and then I just make sure I write my numerator correctly. So it's 3x squared minus 5 minus, and then in parentheses, what I had in the second thing here, 2x squared minus 3x minus 2. And then now I can make sure I distribute the sign correctly. So that's going to be rewritten as 3x squared minus 5. It's going to be minus 2x squared. It's going to be plus 3x because it was negative 3x. And if I'm subtracting it, it's now plus 3x. And the same thing happens to the negative 2. It's minus negative 2, so it becomes plus 2. Again, these are little things that, hopefully you keep getting used to. Obviously, if you can distribute these signs in your head, feel free to do that. But it's always good just to make sure you're being thorough and not making any mistakes, especially with signs, because that can get you the wrong answer immediately, and you don't want to make just small mistakes like that. So anyway, here I just have to combine like terms. The 3x squared can combine with the minus 2x squared, and that's going to leave me with 1x squared, so just x squared here. The negative 5 combines with the 2, so negative 5 plus 2 gives me negative 3. And the 3x can't combine with anything, so I just have the 3x back here. And then my denominator again, all over 3x minus 1. And then this can't be factored or anything really, so that's my final answer. And that's it. So that's just when the denominators are going to be equal. I'll have another video that you can watch right after this. That's the second part to this section where the denominators are not equal.